All right, I'm going to do a little rundown of navigating the Ecolympics website and talking about Ecolympics. So the first thing to do is to navigate to environmentaldashboard.org. That's really all you need to remember. From there, you can click on this Ecolympics button, and it'll open a page that provides links to data on the schools, data on the buildings in the community that are participating, and data on the dorms. And there's a bit of an explanation here. These results are kind of a mock-up for a test competition, just so we can show you what it looks like when a competition is occurring. You'll see these arrows with percent reductions once the competition starts. So the schools will be at the top here for electricity and for water and the other competitions. So there's separate competitions between the schools, between the dorms at Oberlin College, and between these four buildings in the city of Oberlin. So all of that'll be here just for a quick look at things. But the real place to go for anyone who wants to figure out how to win Ecolympics is to the websites that contain data, so you can see what the patterns are like. So we'll click on the school data. That's going to open kind of a home page, and you can see there's a countdown here. This will have like competition results, but we've actually set this one up for the real competition, so it's not going to start until the competition starts. But this is another place where you'll see the results of the competition. In this case, only the competition between the schools, but those will show up here. There's a little bit of comparison school data below there. But I think for most people, what they're going to want to do is go straight to their school. The simplest dashboard for a school is Langston. And if we click on Langston, what you'll see is the squirrel here at the top. And by the way, this is just a glitch. This will hopefully go away, that little drop there. That's not a real thing. But the squirrel shows electricity use so far today in Langston. That's the blue line here that's filled in. The green line is typical use. So that compares, normal patterns of use during the weekdays to the current patterns. And you can see the squirrel was mostly not so happy today. The squirrel's happiness or sadness is how much electricity is being used relative to what's normally being used. So it's kind of comparing the green and the blue line. And since electricity use today was higher than typical use for almost the whole day, the squirrel just wasn't very happy today. So obviously the objective is make the squirrel happy by using less electricity. This little controller up here actually lets you look at data over different time scales. So this is today, but if you want to get real fine, you can look at last hour, and that's going to have minute-by-minute data if you want to like turn appliances on and off and see what it does. But you could look at yesterday, you could look at this whole week, you could look at the last 7 days. I'll just click that just so you get a sense of how these other graphs work. So it's loading data right now, but you can see this pattern of electricity use. And not surprisingly, you can see that patterns last week were way lower than they normally are, and that's because it was break last week. So that makes sense. And then you can see over the weekend there was very little use, etc. So yeah, normally that'll open on today's data. And if I scroll down, you'll see here's the fish, and the fish is looking pretty unhappy too, because water use was higher than typical use. I'll tell you why it was higher than typical use. This is comparing data this week really to a lot of data from last week is what it's using for its typical value. And since last week was break, that's why we seem to be using more than we normally would, because it's using that. But at any rate, here's the squirrel. Really useful to sort of look at patterns in this. I think the key for conserving resources and figuring out how to win the competition is really to sort of be looking at this data and seeing like, where is it high? Why is it high at certain times of day? What can we do to reduce that? So yeah, that's a thing. Like I say, Langston's is simplest because we only have total electricity and total water monitored in the building. This graph down here is just adding up all the schools for the last 30 days for electricity use. So you can see them added together here. See that the high school uses a little bit more electricity than any of the other schools. And then down here, it's kind of the same comparison for water. And one thing you might notice here is it's pretty obvious the high school has a big water leak because it always uses water. On weekends, see how water in the other schools goes to zero? Not in the high school. It always stays at about 4,000 gallons per day, which is crazy high. So there's something wrong in the high school. Speaking of the high school, its dashboard looks a little bit similar to Langston's. It's got the fish and the squirrel at the top, and you can see it's higher too. Again, that has to do with the fact that typical uses incorporating data from over break. There's the fish. You see the fish never goes down below 2,000 gallons, 200 gallons, about 180 gallons per hour, and that's because I think you got a leak in the high school. And then this is interesting. The high school has more things metered. So this is actually electricity use in the high school in the boiler room, the auditorium, the gym, the kitchen, the office. You can see the gym uses a lot of electricity compared to these other spaces. Kind of surprising that it uses so much relative to the kitchen, but that's what the data look like. And then the one that where there's tons of different things metered is actually the elementary school. So I'll click on that for a second. And again, there's the squirrel, there's the fish, and this gives you a breakdown of electricity, of the different utilities going into the building. So it's got electricity consumption, natural gas consumption. It's the only building where we measure natural gas consumption, so that's not part of the competition since there's no one to compete with. And then there's water use in the building. So those are the three utilities, and these are two different time scales. You can see if you look at water use last week, for instance, there's nothing because it's spring break. So there's very little, couple toilet flushes there, basically. And then this is a cool one because this one is the only one that's got solar energy in it because they've got solar energy on their roof, and then the solar array in the back of the field feeds into this school too. So this is kind of interesting. The yellow one here is solar energy production. The purple one here is gross energy use. So it's how much electricity is being used inside the building. But then the green one is net use. So that's what's being read at the meter. And you can see when solar energy is greater than the consumption of electricity in the building, net use actually goes negative. It goes below zero. And that's because the school is actually selling electricity to the grid. That's why it goes below zero. This is how much is going out of the electrical box into the electrical grid and going out to the community of Oberlin. And you can see on a nice sunny day, there's a lot of electricity being sold to the city, which is really cool. So that's that. And then the other thing about the elementary school is we've got electricity broken down by different grade levels, so you can see what grades 1 and 2 are doing versus grades 3 and 4 versus 5 versus the art room. So that's another breakdown we have. This is another way of look. This is the breakdown by HVAC, heating, ventilation, and air conditioning, light energy, and plug load. So we can separate those out within that school too and see how much is going into each of those. And then you can actually, in the kitchen, we've got all this metering in the kitchen, so you can see a breakdown of how different appliances in the kitchen are using it. You can see that dishwasher and disposal use tons of use during lunchtime periods. Those guys just eat up the energy, the electrical energy. And then I also put these groovy heat maps here, which are kind of explained up here, but I'm not going to go into those right now, but they are very, very cool as well. So there's all kinds of nifty data on the schools here, and I'll stop my video there. I guess I'd just say as a take-home point, the thing to really have them think about and brainstorm on is how to sort of what are the patterns in here, and what could they do to change those patterns and make them lower for both electricity and water use. So that's the real question to get them thinking about. All right, I'm done with this video.